Hello everyone. In Vision 2047, India has set herself some ambitious targets to reduce carbon dioxide emission. By 2047, India aims to increase its renewable energy production by 67% of total energy produced. However, renewable energy sources are intermittent, climate, and weather dependent. This can cause grid instability and interrupted power supply. And I'm Lakshmi Narayana Manickavasagam, a PhD scholar working with Dr. Nitin Muralidharan in the Department of Chemical Engineering, IIT Madras. And here, I present my work on seawater energy accumulator for long duration energy storage applications. So if you look at some of the projected technologies, to store 4.85 terawatt hours of energy, which is a very large amount of energy, hydrogen at 700 bar pressure requires nearly 40 into 10 power 5 meter cubes of volume, which is a very large volume. And similarly, liquid hydrogen, liquid ammonia, and liquid methanol also requires pretty high volumes. However, energy stored in the form of metallic sodium in seawater battery requires 5 times lesser volume than hydrogen at 700 bar pressure, thus making SEAL an interesting system to work on. So what is a seawater battery? Seawater battery consists of an anode compartment and a cathode compartment separated by sodium superionic conductor Nasicon solid electrolyte. The energy in these devices are stored in the form of sodium metal plated during charging, and the continuous flow of seawater acts as an infinite source of sodium plus ions. So how do we make these batteries? Seawater batteries are made using prevalent technologies. The anode compartment is similar to what you see in a conventional sodium ion battery. The sodium superionic conductor, which acts as a solid electrolyte and a separator, is similar to what you see in a solid state battery. The compartmentalized design and the OER-ORR reactions are similar to what you see in fuel cell or electrolyzer. And the continuous flow of seawater through this system is similar to what you see in a flow battery. My research involves development of Nasicon as well as electrocatalyst for OER-ORR reaction. These developed materials are then tested in indigenously designed prototype seawater battery. And here is a representational charge-discharge cycle of a seawater battery assembled with in-house developed materials. So seawater battery is a paradigm shifter. India has nearly 7,000 kilometers of coastline, including the islands, and it provides us infinite access to seawater and thereby sodium plus ions. The use of abundant seawater is devoid of toxic critical materials such as nickel, lithium, and cobalt. The continuously flowing seawater acts as a natural coolant, thereby requiring no active cooling system. And in addition to being a grid-scale energy storage device, seawater batteries can also be used in light buoys, life jackets, and any maritime equipments. And since it stores energy in the form of metallic sodium, it delivers very high volumetric energy density of 6.3 kilowatt hours per liter. And this system can also be adapted as a desalination system. Thereby, in addition to addressing India's energy need, seawater batteries will address energy, water, climate nexus of India. Thank you.